advanced concepts of MapReduce. So guys, our agenda is anatomy of MapReduce, where exactly we are going to see n number of different new components, starting from MapReduce workflow, Hadoop data types, mapper, partitioner, combiner, reducer, and a number of different components apart from these. Then different input formats and output formats. Let's start with again a sort of small recap for all of you guys. MapReduce at higher level. MapReduce job submitted by a client. Suppose if a client is submitting the MapReduce job to my cluster, firstly he need to interact with master node, right? And who is the master daemon for the MapReduce? Job tracker. So in all, a client need to submit MapReduce job to the job tracker. Job tracker who is in the continuous contact with the task trackers. So it will invoke the typical task instances. The task instance can be a mapper task or a reducer task according to the requirement. It instantiates the different tasks here. We understand this very well. I think we have discussed the same thing almost 4 hours. So it's like whenever first my job is submitted, firstly the mapper will be running, that will be processing one block at a time. On the other hand, after all my mappers finishes, then my reducer will start, then all reducers will be running, and then the output of the reducer is the final output. Okay, let's move ahead. Now few basic terminologies. I'm repeating, it's almost a recap for, I think, for all of you guys. What is a job? Job is a full program that is an execution of a mapper and reducer across a data set. So all of you understand the job now very well. MapReduce job, typical terminology that we are using. So that is an execution of two processing layers. One is the mapper and second is the reducer. So my job is getting executed with the data set with these two states, that is mapper and reducer. Now what is a task? An execution of a mapper or reducer on a slice of data, that is called a task or task in progress. What is task attempt? So guys, a particular instance of an attempt to execute a task on a node. Guys, as we have already discussed that there is a possibility at any point of time any machine can go down. Suppose while processing the data a machine or a mapper crashes or a JVM crashes, or there are some issues, IO issue, heap issue, some issues are there. What my framework does, it reschedule the task to some other node. By the way guys, anybody knows how many task attempts are there? By default, how many task attempts are there? So if my mapper fails, suppose if my mapper fails on node slave 1, then it fails on, suppose it was rescheduled on the slave 3, again it failed there. Again it is rescheduled on slave 10, it failed there. So this can't be infinite, right? All of you guys. Not really, Ratkal. How it can be equivalent to replication factor? Suppose at that moment, if we are facing the issue related to heap, due to other application has occupied more memories, right? So we can't make it like equals to the replication factor. No, Deepak, I think Deepak also answered the same. Guys, please note down the default value of task attempt is 4. The default value of task attempts is 4. If a task, that is a mapper or reducer task, is failed 4 times, then your job will be considered as a failed job. You can have a number of different type of things like unhandled exception, like any other system related issue that we have discussed. Okay, is this clear, guys? In this manner, my MapReduce job is getting executed, and if in case of failure, it is rescheduling that task only. But this rescheduling of the task can't be infinite. I need to put a upper cap on that. By the way, guys, usually what happens for the high priority jobs, usually people increase this task attempts on a big cluster. Suppose I'm having a cluster of 100 nodes. So there, if means 100 node cluster, you can imagine the traffic also I'm having. So with 100 node cluster, thousands of users, petabytes of data, thousands of MapReduce jobs running parallelly. At that time, if some job is getting stopped, some task is getting failed. So let's make it instead of 4 to 6. So guys, today's session, my expectation will be a little high in terms of smileys, because we are going to cover a few advanced concepts. Master node runs job tracker instance. Master node runs job tracker instance which accepts job request from the client. Task tracker instances run on the slave nodes. We know all these things pretty well. Task tracker forks separate Java process for task instances. Now guys, we all of us can recall, right, each and everything. Let me show you once again the architecture if anybody is not able to recall the things. Look at this. This is how my specific end-to-end execution looks like. I am having 100 TB of data which is divided into blocks. So I am representing these triangles, blocks as these triangles. One mapper is similar to one Java process. Now guys, understand this. I'm having one question for all of you. One mapper processes one block at a time. So I'm marking this brown circle as a mapper. That is a Java process, although there is one another daemon, there is one another process, that is task tracker is running. Now one mapper is processing one block, that is 64 MB data at a time. So when the task tracker is forking, these mappers, these are not threads. These are heavyweight Java process. Your mapper, your typical JVM needs to come into the memory. Your JVM will get initialized. Your JVM will get will get start. All such process will be happening. So my question to all of you is, why it is not threads? Why it is Java process? All of you guys, anybody would like to answer? I think Java experts can answer right away. Unit wise compilation. No, Shravan. Synchronization. Not really. Waiting few more answers. Okay, Deepak is saying within same process JVM, multiple threads are not guaranteed of perfect concurrent processing. I would consider this as a one point. Could you please explain what you just explained? Okay, Ratkal, I'll repeat once again. So meanwhile, guys, all of you think about it. Why it is a heavyweight Java process? Why not threads? Because my threads will be quite lightweight. And it would be very easy. It would be even less costly for me. It would be pretty less costly for me to have a threads, because the initialization of thread would be pretty easy. But there is a very, very big reason why I am having heavyweight Java process. So Deepak is saying in same JVM, the memory that the JVM get is what all threads need to share. Correct, Deepak, again another valid point. Shravan is saying for faster processing. Okay, but I would say just okay with this. Think about it, guys. Once, let me explain the complete flow once again. I'm having, okay, let me use the highlighter as well. Oh, no, Ratkal, not really. I think you're going in the wrong direction. So guys, I'm representing my mapper as this brown circle and block as this red filled block, red filled triangle. So my 100 MB data, 100 TB data is divided into small and number of thousands of blocks. When I copy the data, my blocks will be stored on all the nodes in the cluster. It would be distributedly stored. It is distributedly stored on all the nodes in the cluster. Now, I am having my data already available here. Now, when clients submit an algorithm, when clients submit the algorithm will be submitted on the job tracker, which in turn submit algorithm to task trackers. So my algorithm will be moving from client to master to the slaves. So here on each and every node, my algorithm is running. Firstly, the mapper will start. So this is how my mapper look like. So once my MapReduce job submitted, task tracker is also a process, by the way. Task tracker, folks, a Java process. Job tracker starts a Java process. Job tracker initiates a Java process with which another JVM will start, initialize, come into the memory, then all the processing will start. As soon as JVM finish, it will be stopped and it will be deinitialized. That is a costly process. All of us knows it very well that Java start and stop is always a costly. So what I am asking is, why it is Java process? Why not just a thread? Let's start a thread. Suppose I am having, say, 10 mappers. 10 mappers are running. If I configure it like that way, that 10 mapper runs at a time. I think I have already shared that parameter with you, that property with you in last session. So if I am having 10 mappers running here, why it is not threads? Why it is Java process? Please note down, this is an assignment. Ayush, if you can post this on the forum. So this would be quite a good, interesting topic for all of you guys. I recommend all of you guys answer this. I want 12 answers for this question. Means for limited questions, I request all of you guys to answer. Even non-Java guys also, like Ratkal Shiva. No, Ayush, not really. No, Shravan. Okay, let's move ahead. Let's stop this thing. Please note down, this is an assignment. So guys, this is the overall picture of the MapReduce, basic MapReduce show. This architecture diagram shows just an overview. I'm having input data. That input data is stored in all the nodes. When I'm submitting the MapReduce job, firstly the mapper come into the picture, which processes the data one block at a time or one split at a time. Output of mapper is intermediate output, intermediate data, which is getting shuffled and then sorted. Then reducer come into the picture. Now the processing, after processing in the reducer, my output will be the final output. The final output is stored in the HDFS again. So these are the two processing elements, mapper and reducers, where we write our own custom business logic. If I can get a smiley, if I can get all these smileys means from all of you guys, if it is 100% clear, not a single doubt, because the next architecture that I'll show you, that would be much deeper level. Okay, I got few big smileys also. Thank you. Now guys, just after this slide, I'll show you once again that advanced architecture, which will be having all the components. Let me repeat few more things also here. So I'm having n number of different chunks. N number of chunks are there, which are getting processed by mappers. That is, one mapper is processing one chunk or one block or one split. The most correct word would be split. Please note down this. One mapper processes one split. What is this split? Everything I'll explain in next few minutes. Output of mapper, that is the intermediate output, IO0, IO1, IO2, IO3 and so on. This intermediate output gets shuffled. The output gets shuffled and the data goes to all the reducer. Now output of each mapper goes to all the reducers, or each and every reducer get the input from all the mappers. Now after processing of the data here, so that's shuffling. After processing of the data here in the reducer, we write final outputs. So that's overall flow of MapReduce. In MapReduce, chunks are processed in isolation by tasks called mappers. The outputs from the mappers are denoted as intermediate outputs that are brought into second set of tasks called reducers. This shuffling. The process of bringing together intermediate outputs into a set of reducers is known as shuffling. And after the data reaches here, my sorting will start. The reducer produces the final output. The output of reducer is final output. Overall, MapReduce breaks the data flow into two phases. One is the map phase, second is the reduce phase. One is the map phase, second is the reduce phase. Now, I'm having Hadoop data types, custom data type. Okay guys, I'll cover these two slides a little later. Let's talk about MapReduce, a closer look. Let's talk about this. Then after that we'll cover last two slides, basic data type of MapReduce. Suppose I am having these two slaves, node 1 and node 2. These are my two slaves. On each and every slaves I am having some files, or you can say some blocks are stored, right? So that is data that is local to that HDFS. HDFS data that is local to that node. What I mean by these data on a node means the data that is the blocks that is local and stored inside this HDFS. Now, the very first component when we submit a MapReduce job is InputFormat. All of you guys, please note down this. So guys, by the way, whatever things today we are discussing is very important from the perspective of interview as well as certification. Hope you have noted down InputFormat. So, how to read input files, or even I should say how input files are splitted and read is defined by how input files are splitted and how to read these files are defined by InputFormat. I hope all of you are noting down. So by the way, in next few slides, just note down just keywords like InputFormat, like what it does, read and split. The work of InputFormat, the functionality that InputFormat provides is it selects the file, or even I should use correct word, it selects the object that should be used as an input. It selects the object that should be used as an input. My InputFormat's first work. It defines InputSplit that breaks a file into tasks. This is the responsibility of InputFormat to define a split. What is a split? I'm just showing you in next few minutes. Apart from that, it is only InputFormat that provides the factory for the RecordReader object. It provides factory for the RecordReader object. Now, so guys, overall we understood that yes, there is a component that is an InputFormat which will come into the picture, whose work is to provide the mechanism that how the data is split, how to read the data, or it provides a factory for the RecordReader, it defines the InputSplit, and the main thing is that it selects the input. It selects the output objects that should be used for the input. this overall work is of my input format. Okay, I got one first question initially only. Can you please repeat if input format breaks the block relevant to the node or whole file that the job is supposed to process? Deepak, please understand this carefully. All of you guys, please understand this carefully. I am having my data already splitted. Already data is divided into chunks. Whenever my data was stored, whenever I am storing my data in the HDFS, my data is already splitted, already divided into blocks, already divided into physical chunks. Okay, so my data is already available here. That is the task of HDFS. Now I'm not talking anything about the storage layer. I'm totally at the processing layer. I'm showing you this particular picture, this particular architecture when you, as soon as you submit the MapReduce job. So when you submit a MapReduce job, there is no need of like you break your data or like you break your file. Deepak, hope you understood. No, Deepak, it is not really block that is getting split. It is defining input split. What is input split? I'm showing you. Wait for some time. Correct. This is explanation of exactly internal implementation, how it works. Correct, Shiva. So guys, I'm again explaining the same. As soon as we submit the MapReduce job, we have seen that what happens as soon as we submit the MapReduce job. As soon as you submit the MapReduce job, my blocks is given as an input to mapper, then output is returned, then shuffling, then reducer output like this. But this is not really the complete flow. How my data is going from HDFS to mapper. They are in between, three components are there. I'm showing you the same thing here. Guys, I'm repeating. I'm having two nodes where I'm having, say, these are the data that is stored, file or blocks. Input format, the very first component that come into the picture, whose responsibility is define the input split. It defines the input split. It selects the input object. It selects the object that will be provided as an input to my mapper. It provides the APIs. It helps the record reader to read the object, to read the file, to read the data. So guys, the default input format which we are using till now, please note down. Anybody knows, by the way, the default input format which we are using? The default input format that we are using is text input format. Please note down this. The default input format, that is text input format. Wait for some time, Ratkal, you'll understand. As soon as I have finished the complete flow, you'll understand surely. As I told you guys, input format defines the input split. Input format defines input split. Now what is input split, guys? Please do note down all the definition, all the things are available in next few slides. You understand, you try to understand it here. Don't worry, if we are not getting the things in one time, I'll repeat it once again. I can repeat it n number of times. I'm not having an issue. Please understand this carefully. Input split defines the unit of work. By default, input one split is equals to one block. By default, one split is equal to one block. So let me give you a very simple definition of a split. A split is the logical representation of a block. Split is the logical representation of a block. All of you guys, now I think split would be very easy for you to understand. My data is divided into blocks by HDFS. That is a physical partition. That is a physical data. But logical representation of the same block is a split. So note down this: split is equals to block by default. So guys, InputSplit defines the unit, the basic unit of work that comprises the single map task. Now guys, initially in the MapReduce session I told that a block is given as an input, but now I am updating my terminology. A split is given as an input to a mapper. One mapper processes one split at a time. Correct Shiva, whatever is your block size, it is going to process the same. Is InputFormat a framework or a, what you are asking, Ratkal? InputFormat is surely not a framework. It's not an algorithm. You can consider this as a component here, which help you to read the input data and provide it to your mapper. This is the component that is actually helping. Means you tell me how my mapper is getting the data. InputFormat is defining the input split. Now split is mapped to a block, and in this manner my data is getting input to my mapper. Correct. Mapper uses InputFormat internally. So InputFormat, guys, we have seen InputFormat is the default input format that we use is text input format. Then InputSplit, that is the basic unit of work. Basic unit of work. It means one mapper. This is the lowest unit of work. That is one mapper processes one split at a time. Now the next component is the record reader. Guys, understand record reader carefully. By the way, I'll repeat the complete flow once again for all of you. Don't worry. What is a record reader? Record reader is the class that actually load the data from source. It actually load the data from source and give it input to the mapper. Record reader is a class that actually load the data. On the other hand, InputFormat and split provides it, help it. InputFormat provides the factory to the record reader. InputSplits is a logical representation of the block. So these are just simply helpers for record reader. On the other hand, record reader is the class, record reader is the main class that actually read the data and give input to my mapper. Now I think Deepak asked me in the, I think, second or third session only, that how my flat data, flat file or unstructured file is converted into key value pair. Right, Deepak? I can't recall who asked this. I think Deepak. So record reader is a class that converts the data, into key value pair. Of flat data is converted into key value pair by the record reader. Now guys, again, record reader itself is customizable. InputFormat itself is a customizable, or we can customize the split also, like we can give 1 or 2 split to a mapper. Everything is customizable, and we are going to see lots of customizations. I'm repeating the record reader again for you. So guys, we have understood that, okay, InputSplit. What is InputSplit? This is a slice of work. This is a unit of work. Record reader class load the data. Record reader class load the data from its source and convert it into key value format. Because my mapper understands the data that is only in the key value format. Mapper understands only key value. On the other hand, record reader is defined by the input format only. Record reader is defined by input format. All the functionality of the record reader, it is defined by input format only. So guys, as I told you, the default input format is text input format. On the other hand, the default record reader is line record reader. Now try to recall our first discussion of key value. What is happening with the text input format? We are getting one line at a time as an input. My byte offset is a key and complete line as a value. Correct, Shravan? All such functionalities provided by text input format. If I change my input format, my functionality will be changed. Like if I use key value input format, the way it is presenting the key and value to the mapper will be changed. If I use XML input format, again the key and value that is presented to the mapper will be changed. So guys, it is the responsibility of my input format to provide a mechanism to define the class, how to provide the data to mapper. I can write my own input format class. By the way guys, we are going to write our own input format class also. Input format is simply a mechanism. It's simply a representation. Input format simply defines few things. It helps the record reader. It defines the input split. It selects the input object, input data. That's it. That's the work of input format. Now guys, I'm again repeating from my old explanation how exactly I was explaining you earlier. This is my block. One block is provided as an input to a mapper. One block is provided as an input to the mapper, but how this data travel to the mapper? The very first question, how the data is converted into key value pair? How mapper is reading the data? That is, mapper is getting, my map method is getting just one line at a time, one key value at a time. Second question. Third question, is my mapper itself is going to the file level, is going to the block level and reading the data there? Or is there any logical representation? How my data is getting read? How my data is getting read and converted from one format to another? That is in the key value format only. So guys, if the things are getting clear for you, we do not need to go in the internal details of each and every one as a programmer, as a user, but this is what that is happening in the background. All these things are happening, all these things are running in the background. That's the actual flow of MapReduce job. If it is clear for all of you, if I can get a smiley. Whoever it's not clear for them, just ask, miss, I'll repeat again also. No issues. From the scratch I can repeat. Sure Nikita, I'll repeat. One request I got. Sure Atkal, I'll repeat. Second request. What is more important, recorded or split? Chetan, everything is important. Okay, fine. I'm repeating again from the scratch. Look at this carefully again. Don't note down anything, just watch it. I have got my data as an input. I have got my data that is available in HDFS, which I need to take as an input to my MapReduce job. As soon as user submits the MapReduce job, as soon as user submit a MapReduce job, my job is submitted on the job tracker, and task is submitted on a task tracker. So what I'm showing you here, how exactly it is running on these two nodes. Firstly the map task will be running, then the reduce task will be running. Now here how my mapper runs. So firstly the component that come into the picture is the input format. So input format is the class which actually defines the input split. Means it tell mapper that boss just read the data from split, because my mapper will get the data from the split. Or if I show you the record reader also, my record reader will be getting the data from the split before it present the data to the mapper. Again in some other language, it helps, okay, it load the data, it read the data. How means, even I shouldn't use the word read the data, because reading is done by the record reader. My input format helps in reading the data, or it defines how to read the data simply. Is this clear all of you guys? What my input format is doing, it helps to read the data. It defines the input split. It selects the object. It itself selects the object. Whatever is given as an input, it knows it will select, suppose this object as an input. This my block object as block as an input. Also it will provide the factory to read for the record reader to read the data. So input format has defined an input split. That is a unit of work. Unit of work means basic unit means the lowest unit. That is a single map task. It describes a single map task, or in other word I can say a split is the logical representation of your block. Block is the physical split, on the other hand block is the physical division, on the other hand split is the logical division. The third component is the record reader. Now till now we understand that, okay, input format helps in reading the data. It defines the split. It defines how to read the data. It helps the record reader to read the data. Record reader is the actual class that read the data and convert the data into key value pair. So again repeating the definition of record reader. Record reader load the data from its source and convert it into key value pairs. My record reader is defined by input format only. So with each and every input format, if you have written your own input format, say XYZ, that input format will be having its own record reader. Now guys, another thing, understand this carefully. My record reader is invoked repeatedly on input data until the input split gets consumed. This record reader is getting invoked again and again. This record reader getting invoked again and again. At a time it reads one key value pair and gives to the map method. Then second time, suppose I am having 1000 key value pair, so 1000 time my record reader will be invoked. Is this clear guys? How I am getting just one key value pair at a time? It is reading the data from the input split. And converting it into key value pair and presenting it to my map method. After map method my map method process the key value, then again record reader will be invoked. Record reader again read the next key value pair here and give the data to map method. Map method again process the same. This particular activity continues until and unless my complete input split is getting consumed. Ratkal, Nikita. Okay, good. Chetan is asking input form. Chetan, input format, not input split is the unit of work. In unit of work, input split. Shiva is asking if input format is XML, then also it reads line by line and generate key value pair. No, Shiva, how I can read an XML line by line? I can't read XML line by line, right? I need to read XML tag by tag. That will discuss. Don't worry about that. How exactly what will be a record, because your record reader gives one record to your input format, one record to your mapper. That I'll show you. We are having one session for specific to that. By the way, there is no XML input format that is shipped with Hadoop. We need to write our own input format. I'll show you that implementation also. Mapper output is stored on the local disk. Correct, Kalyan? Mapper output is stored on the local disk. Shravan is asking one record reader per one mapper. Yes, Shravan, but it is getting invoked a number of times. So rather than understanding it one record reader per mapper, no, I would say a record reader is getting invoked n number of times, where n is equals to number of key value pairs. Okay. Deepak is asking, so we need a custom or non-default record reader for XML to read one XML node at a time. Correct, Deepak. At the input format level, we need to write a new input format. So our default input format, that is text, that is considering one line as a record. It is considering one line as a record. I need to write a new input format. Suppose you write another input format, that is Deepak input format. Whatever you want, you can do at that level. Simply what I'll be doing at the input format level, I'll be reading the data at the byte, in the byte format. I'll be reading each and every byte. So whatever functionality I want to do, provide at that level, I can provide it. Okay. Invoking of recorder is done by input format. Yes, your input recorder is again getting input format. So even Shravan, usually it is used as a what should I say, generalized term. It's getting invoked by the framework, but yeah, it's correct. So if I need to read the JSON data, what I need to write? Think about it. Don't answer right away. Means I think the day after tomorrow's session we are going to see the same things. Okay, so guys, what next? The data is presented to the mapper. Now you guys answer this. What next? Mapper is processing my data. Mapper is processing the data and writing the output to the local disk. Correct. My mapper is processing the data and writing the output to the local disk. But there is another component. Mapper is giving output to which? Okay, it is writing to local disk. Let's ignore that. Let's understand how my data is getting shuffled. Where is exactly the logic is? Where is my logic that my specific key is going to a specific reducer? A specific key is going to a specific reducer. What is the component for the same. Let me show you. The output of all the mapper is going as an input to the partitioner. The output of the mapper is going as an input to the partitioner. Your intermediate output or intermediate key value pair is given as an input to the partitioner. Partitioner, guys, again important component. Partitioner, very important component. Understand this carefully. This is the responsibility of my partitioner class to partition the data. To partition the data in different partitions, different parts. My partitioner class defines which partition will go to which reducer. All of you were asking, guys, earlier, if my Hadoop key is going to this reducer or Anish key is going to this reducer, who takes the decision? So guys, the decision is taken care by the partitioner class based on the key. What happens actually? The partitioner class determines which partition a given key value pair will go. The default partitioner. So guys, what is exactly the code here? My partitioner computes hash value of the key. It computes the hash value of the key and assign the partition based on the result. It is getting n number of different key value pairs. What it is doing at a time, it is calculating the hash value of its key and it is dividing it into different partitions. Suppose I am having, say, 10 keys whose partition is same. Understand this carefully. Output of partitioner will be like n number of key values. Suppose here I am having, in the first partition I am having 5 keys and all the values corresponding to that. In the second partition, suppose I am having 7 keys and all the values corresponding to that, and so on. In this manner I'll be having n number of different partitions. This partition will go to a specific reducer, this partitioner will go to a specific reducer. The same key, suppose it is here I am having key called K1 and here also I am having key called K1. Since the logic in the partitioner, since the logic in each and every partitioner is same, so whatever calculation this partitioner is doing, same calculation this partitioner is also doing. In this manner, key K1 and key K1 from both the partitioner will go to the same reducer. Partitioner is the actual class who takes the decision where each and every key value pair goes. It divides the data, it partitions the data into different parts. It partitions the intermediate outputs. So I can say that, guys, out of all these key value pairs, intermediate key value pairs, n number of different subsets are getting created. These are the subsets. Say this is subset number 1, this is subset 2, 3, and so on. I am having n number of subsets for my intermediate output. A different subset of intermediate key space is assigned to each reduce node. So this subset or partitions will be the input to the reduce task. So guys, this is the reason that all the values for the same keys are always going to a same reducer. Hope guys you understand this. Okay, let me erase my drawing. Okay, let me take few questions. Yeah, all of you are asking for the combiner. So guys, I am not showing you combiner here. Surely there will be a combiner. Let's not talk about combiner. Combiner is there if required. If we set the combiner, combiner will be there. Let me erase the combiner. Okay. Output of mapper goes to partitioner. Correct, Kalyan. What do you mean by hash value? Kalyan, we can get the hash value. What is exactly the hash? There is a function available in the Java. I hope you know that. There's a function available with the help of which we can get the hash value. We can get easily. And depending on that, like a particular range goes to a specific place, or particular thing goes to particular value goes to a specific place. When key in itself is referenceable, why does it need to hash that the key to decide on which partition the data goes to? A good question, Deepak. So guys, Deepak is asking, when key itself is referenceable, why does it need to hash the data, hash the key to decide on which partition the data will go? Who will answer this? I would consider this as a good question, and even I'm expecting the answer even from Deepak, you also. Correct answer, Deepak. 1 pointer correct. Ratkal, yeah, I agree. You are saying that same keys will be available across different partitioners, but corresponding to those same keys will be going to get the same hash key also. So what is the need of hash? Oh, sorry, hash value. Key may not be unique always. Shiva, key can't be unique. There will be thousands of the unique same same keys will be there. Key may be longer, whereas hash could be small size. Okay. Now guys, tell me, can you assign a specific range? Say for example, 0 to, suppose my hash range is from 0 to 100, from where I can assign whatever keys hash value is. From 0 to 20 go to the first reducer, 20 to 50 second, 50 to 70 third, 70 to 100 fourth. Can I do similar thing with the directly key? Deepak? All of you guys? Correct, Chirag, we can't have that many reducers. We can't have, say, if I am having 1 million keys, I can't have 1 million reducers. What I am doing, what I am getting at the reducer at any point of time, at any reducer, at any point of time, we are getting more than 1 key, high key and all its values in the reducer, Hadoop key and all its values. So all such input is given to a single reducer only. At a time, 1 key value is going for processing, but all these key value pairs is available for a single reducer. Okay, I got few requests. I think Shravan is asking me to repeat the partitioner. Shravan, we understand in the last session that in the last MapReduce session that my output of mapper is going to a reducer. and I have given you one thumb rule. All the values corresponding to a reducer goes to, all the keys all the values corresponding to same key goes to same reducer. So I am having suppose key called Anish here 100 times and key called Anish here 1000 times. All the keys, that is 1100 will go to the same reducer. Who will decide this? To which reducer my key value will go? Which key goes to which reducer? The partitioner is the class that take the decision. Shravan, clear? So guys, still partitioner. Is everything clear? Yes, Shiva. Yeah. So I got another good question. So based on this approach, if some keys are finding high frequency, suppose a key is called Hadoop is there for say 1 lakh time and rest of the keys like in the 1000 range. Deepak is asking this. Okay. High frequency occurrence in input text and the others are very less. The partitioner is just sending the key to the different reducer regardless of the volume. Correct, Deepak? It will send. It will send. Surely. So if I am having say Hadoop word 1 lakh times or 1 million times, I'll be having 1 million times my word is here. 1 million key value pair is there. No, even I'm talking about a single word also. Let's make it a little simple. Let's simplify the thing. If one word is 1 million times, so this reducer will be running quite long. On the other hand, if all the words here in this reducer is like 1000 times, then this reducer will run quite less time. Ratkal, how we can do the load balancing? This is really a practical scenario. Means are you asking Ratkal to me that I should send 50% of the Hadoop word here and 50% here? That's not possible. That will break down my complete algorithm. It's of no use. It's of no use. My MapReduce code will be of no use. I'll be getting say Hadoop comma 50,000 from here, Hadoop comma 70,000 from here, but I want Hadoop comma 1,20,000. The output will be wrong. Correct, Shiva? Correct, Shravan. Impossible. That's like a rare case, but that happens. That's acceptable. Okay, good. Ratkal, got the things? Won't partitioner have the detail of the number of occurrence of the keys? Ratkal, try to understand this thing carefully. I am having this type of 100 nodes. On each and every node there is a partitioner. Okay. Suppose each and every partitioner is emitting say 10,000. So I'm having 100,000, right? 1000 is not a big word, by the way, big number. And even if one partitioner is getting 1 lakh or 1 million time, then also if you expect that this partitioner will do some sort of load balancing and sending the same key to the different reducer, that would be wrong. Clear? That is, by the way, a very rare case. In the actual data, in the actual scenario, this is very rare. What is next after the partitioner? My data is partitioned. Some of the data is ready for some node, some of the data is ready for some other node. Wrong, Deepak. How the reducer can come this much fast? You didn't send your data. You still didn't send your data. Correct. Correct, Ratkal. First thing is the shuffling. The first thing is the shuffling. My intermediate key value will be exchanged by all the nodes. Shuffling is very costly process, but we can't ignore shuffling. This is the single place where my data is getting, my volume of data is getting travel across the network. These volumes can be high. If I'm processing petabytes of data, I'm having very high volume that is traveling over the network. So there are few mechanisms, by the way. We can compress the data that is the output of your partitioner, output of your mapper or partitioner. This output will be compressed, and the compressed output will travel from here to here, and here it will get uncompressed. There are few optimizations are available like combiner. Combiner will reduce the data, like compression. But yes, my data needs to travel. Okay, so before I explain the sorting, let me take one question. Partitioner only determine where what key goes, but the shuffle really does that. Correct, Deepak, your statement is correct. After shuffling, the next component is the sorting, which sorts all your data based on your key. The sorting is based on the key. So if anybody can recall the output of the MapReduce job, it was like each and every key and value, that is word and its count, each and every word and its count was in the sorted order by the key. I am having the data in the order A, then B, then C, then D, in that order. Can anybody recall the output of MapReduce job, or if you can see the output of MapReduce job at his virtual machine, on his virtual machine if he's having? Correct, Deepak. Okay, only Deepak has observed that. What about rest of the guys? I'm not sure whether all of you have submitted at least one MapReduce job, at least word count. Okay, two guys, Deepak, Ratkal. So after the sorting, my data will be given as an input to the reducer. Reducer is the second staging, second place, second space where I can write my custom business logic. Whatever I want to do with the data, I can do here at the reducer level as well, where I'll be having all the values corresponding to same key, whatever I have sent from the mapper. After the reducer, the data will be given as an input to the output format. So guys, output format you can simply understand as another way of input format. Input format defines how to read the data, output format defines how to write the data. And I'll be having RecordReader, which will be writing the data to the HDFS store. This is the overall actual flow of the MapReduce job. What is happening behind the scene? What is happening there? Input format split, input formats which define how to read the data, which defines the input split, which help the record reader. Input split, that is a logical representation of your block. Record reader, which actually load the data from HDFS, which convert the data into key value format and give the data to the mapper. Mapper, your input, place where you can write your own custom business logic. Your actual Java code resides here. My mapper's output will given as an input to the partitioner. Partitioner take the decision where the key will go, on which reducing node my key will go, my key value will go. At the reducer node, I'll be having the sorting. All my key values will be sorted, all my data will be sorted according to keys. Then they are presented as an input to the reducer. Reducer second place where I can write my custom business logic. Second place where I can write my custom business logic. Then reducer will give the data to output format, which defines how to write the data. The data will be written by the record writer. Think about it, guys. Let me take few questions meanwhile. Mapper input in HDFS, mapper output in local disk, reducer output into HDFS. Correct, Kalyan. Partitioner sort 2 can be custom implemented just like input format or RecordReader could custom classes. Yeah, Deepak, you can write the custom sorting also. So by the way, custom partitioner also we are going to see. Custom partitioner we will see, but usually it's recommended to not go for the custom sorting because it's little costly. You can surely go for that as well. So each and every component is customizable, by the way. The most important out of which is input format. The most important. Input is key value pair. Shiva, input to the mapper is key value pair and output is also a key value pair only. Intermediate output is again in the form of key value pair. It must be key value pair. It can't be VK. If everything is clear for all of you guys, if I can get a smiley. 100% clear. 1, Chirag, good. Shiva, Ayush, okay. Okay, that's good. I got one surprising smiley also. What happened, Kalyan? Okay, okay, fine. I got a smiley. That's good. So guys, the next few slides we are going to go in more detail about each and every session, about each and every component. But before that, what I want, guys, please go through today's session's recording before I explain each and every component in great detail once again. Because otherwise it would be like in the one day, if I finish the complete thing, it won't be that much digestible. So before the next session, make sure you watch the complete recording. That's it for the day, guys. So I'm open if anybody is having any questions. Appreciate the initial architect. Okay, thank you, Shiva. How is the size occupied by all these components? Shravan, these components are individual classes. These are the normal Java classes. No, not really. They are occupying any size. What do you mean by checkpoint? Kalyan, if I mentioned checkpoint anywhere? I don't think so. Okay, you're talking about the name nodes checkpoint, right? Okay, wait for some time, Kalyan. Let's talk about the whatever I'm showing you here. So please ask the question about here. What is happening here? Whoever has done this architecture. Shiva, the architecture is developed by, I would say, mainly Facebook, Google, Yahoo, IBM, and a number of guys in the open source community. Everybody is appreciating that due to this architecture only the data is means the Hadoop is that much powerful and popular. Chetan is asking what is shuffled between node 1 and node 2. Chetan, this intermediate output, whatever you write as an output from the mapper is getting shuffled. Anybody else is having any questions? Okay. Yeah guys, that's it for the day. Make sure before the next session you go through the complete recording so that in the next session we are going to cover each and every component again in the great detail. What are the n number of input formats, how to override define new record reader, new partitioner, new input data types, a number of different things we are going to see, the complete class hierarchies. Example on shuffling. Chetan, you think about it once again. Example on shuffling. Okay, let me show you here. The output of my mapper is this intermediate output, right? If you can recall the word count example, hi comma 1, Hadoop comma 1, MapReduce comma 1. Chetan, this is the actual example. This data this hi is going from here to here. Hi is going from here to here. From here to here. Okay? Good. Alright guys. Thank you so much. Tomorrow, same time. Have a good night. Bye bye.